Okay, let us start. And today we'll discuss a new topic, that is steam and its properties. Steam, we all know, is a gaseous phase of water. So steam is formed from water by heating water. The steam utilizes heat, and the steam carries a large amount of heat, and this steam has some special properties which helps us to use steam as a working substance, heat engine as well as in steam turbine. All these things we'll discuss in this chapter. And steam is generated in a special equipment called boiler, in which heat is added to the water. So in a boiler, steam is added by burning fuel, and by this heat is transferred to the water, and that water upon continuous heating will form steam at the end. So let us see how steam is formed, and also we'll discuss about some properties of steam. At the end of this chapter, we'll discuss some properties of steam. But before that, we'll see what is steam and how steam can be formed under different conditions. Okay. So before that, we should know what is a substance, pure substance. A pure substance is a substance which is uniform in chemical composition. We know the chemical composition of water is what? H2O. And this composition remains same when the phase changes. Water may exist as in the solid phase, that means ice, as in the liquid phase, which we call water, and also in the vapor stage, which we call the steam, or that is the vapor stage of the water. So in all these three stages, or better to say phases, the composition remains same, chemical composition, that means two molecules of water combined with one molecule of oxygen. This is the chemical composition throughout the phases. In any phase, this is the composition. And this type of substance are called pure substances. And water is a pure substance, and this is very important in engineering application. It has many applications, and we can produce power by doing so. Steam is one of the most important pure substance in engineering. Okay? It is used and studied. So steam we'll discuss how steam is used, and we'll study the properties of the steam. And steam is used as a working fluid in steam engine, also in steam turbine, in steam condenser, also in steam boiler. But basically it is used in steam engine and steam turbine. But you have to note the thing that nowadays steam engine is not used anywhere in the world, because this is an obsolete thing now, because it has a low thermal efficiency or some disadvantages. And earlier steam engine was used in many applications, like, okay. So we'll discuss water as a pure substance. Pure substance, we have already mentioned that it's a, what is that characteristic of a pure substance? The chemical composition remains same, although we heat it from solid to liquid, liquid to gas, and at any phase the chemical composition remains same. Now that means water has fixed chemical composition throughout the phases. It remains H2O, two molecules of hydrogen, one molecule of water. Okay. Now we will discuss, say we consider 1 kg of ice. This is ice. We consider 1 kg of ice. So ice is what phase? The solid phase of water. Now if we add heat to the ice, say Q is the amount of heat added to the ice by any means. We can burn fuel and add heat to the ice. Then what will happen? Upon heating, if we heat what will be the thing? We all know the ice will melt at some point. That we will discuss in detail. Ice will melt and it will be converted to water. Again, if we continue heating water, it is continuing, heating is continued, then finally it will become steam. And this way, if we add heat to ice, that means solid phase, it will become liquid, that means water. And upon continued heating, water will become vapor, which is the gaseous phase of water. Now, think of the reverse. Suppose we are talking about heat supplied. Okay. Now we are considering heat rejected. Say we are rejecting heat from steam somehow. Then the steam will become, this we will call heating. Opposite of heating is say cooling. Upon cooling, that means upon rejection of heat, steam become water. Okay. And again from water, if we reject heat, that means if we do the cooling, if we cool it, then it will become again ice. And this way the phases of water may change depending upon the amount of heat added or amount of heat rejected by the system. This is the system. That means a particular mass of ice, upon heating it will form water, and the same mass of water upon heating it will form steam, and the reverse will take place, which we reject or extract the heat from the steam or water. Okay, so just imagine we take first, you look at the first diagram, first part of the diagram, in which we take 1 kg of ice in a piston cylinder arrangement, in which a particular piston is given and some weight. Weight means, ultimately weight means pressure. Force, weight means force per unit area is pressure. So this will remain at constant pressure. Whatever be the condition, it will remain at constant pressure. Now, suppose the ice temperature is Ti. Ice stands for ice. Temperature of ice is Ti degrees centigrade. Okay, if we add heat to this system, supply heat to this ice, then what will happen? Okay.
Ice to
Melting. In a sense, you are right, but we will analyze the thing technically. We'll go deeper into the thing. Suppose we add Ti degree centigrade, it is much lower temperature, suppose. So that means if we add heat to the ice, first what will happen, it will not melt immediately. What will happen? The temperature of ice will increase. Okay, so at a particular temperature, the temperature will not increase. That means at that point, the ice will start melting. And when it starts melting, that means temperature will not increase. But what will happen to the heat? That means heat added to the system is used to transform the phase from solid to liquid. Okay, so first the temperature will increase, then at a particular temperature, say T0 degree centigrade, at T0 degree centigrade, the melting begins, and after this is fully 100%, it will be 100% water now. After some time, the melting is not an instantaneous thing. Melting starts and it will continue for some time depending upon the amount of heat it receives. And please remember, the pressure from the top is always constant, same pressure. So when the melting completes, then what will happen? That means 100% water. At what degree centigrade? T0 degree centigrade. T0 degree centigrade. Melting is complete. Then what will happen? Yes? Okay.
Temperature of water will increase.
Very good. So at that point, the temperature of water will start increasing from T naught degree centigrade, and then only temperature will increase. It will not evaporate at that point. So what will happen? The temperature will increase up to say Ts degree centigrade. Then this Ts is called saturation. Saturation temperature at which the water starts boiling, that is called boiling. The phenomenon is called boiling. So when the boiling begins, the temperature will remain same. It will be fixed for some time, and that also depends on the amount of heat supply. So there will be a point at which the boiling begins. Means, what is boiling? Boiling means conversion of water to vapor. And say this part is vapor and this part is liquid. That means amount of vapor will increase and amount of liquid will decrease. And at some point, the boiling will be completed. That means there will be no more water particles in that space. That means this is 100% steam now. This is 100% steam, or we can say vapor. So till now the temperature will remain Ts degree centigrade. Okay. So first what will happen? Water at Ts degree centigrade. That means boiling begins. That is 100% water. Now gradually what happened, the amount of water will decrease, but amount of vapor will increase, because it cannot go out. This is the piston cylinder arrangement. So what will happen? The water will start absorbing heat, start taking heat, and that heat will transform the water to the vapor. And at a time there will be no vapor, 0% water. Now this is 0% water. That means 100% steam, and that type of steam is called dry steam. This is called dry steam. And before dry steam, when the water is not completely evaporated, that type of steam is called wet steam. That is called wet steam. So you just look, ice become what? Ice temperature increases, then completion of melting happens. That means that time it is 100% water. Then when it is wet steam, from 100% water it will go to 100% dry steam, and during this process there will be no change in temperature. Now just imagine, when this 100% steam, if we add more heat to the system, then what will happen? Then again the temperature of steam will start increasing. If we add heat to the dry steam, that means 100% steam, then again temperature will start increasing, and that is called superheating. If we heat dry steam, that is called superheating, and that type of steam is called superheated steam, and that we represent by T sup. Subscript sup, that means temperature of superheated steam. Okay, from ice we can get superheated steam or dry steam. And if we do not consider ice, suppose we do not consider, because at atmospheric temperature generally we get water. In our environment we get water, not ice. In winter it may be ice somehow because of the too much cold. So from water we can make dry steam, or we can produce superheated steam. For that, what we have to do? We have to add heat to water. Then water temperature will increase. Then at a point the temperature will not increase, and that means that temperature will not increase means evaporation begins, and During evaporation, the temperature will not increase, and at a point when the evaporation completes, that phase we call dry steam. And if we continue heating, then dry steam become superheated steam, and temperature of superheated steam will go on increasing if we go on increasing the if we continue the addition of heat. So this is how the formation of steam takes place. Now we are considering that a particular pressure P is applied at any time. That means pressure is constant. So this is a constant pressure process. Okay. Now just tell me, if P is equal to 1 atmospheric pressure, then what is T naught? T naught to Kiman temperature at that point, if it is atmospheric pressure. At what temperature ice melt? That is called melting point. That is 0 degree centigrade. When the pressure is at 1 atmospheric pressure, then ice melt at 0 degree centigrade and water boils at 100 degree centigrade. This is called boiling point, that is called a melting point, boiling. And this is true only when the pressure is atmospheric pressure. But if the pressure is higher than the atmospheric pressure, then the melting will take place at higher temperature, more than 0 degree centigrade, and boiling will take place at higher temperature, that means more than 100 degree centigrade. And that is why the pressure is important. If the pressure is more, then boiling temperature will be more. So in all these cases, we can say, what is a saturated steam? Dry steam. What is a dry steam? Dry steam is a steam in which there is not a single particle of water suspended with the steam. Generally, when we boil something, some particles of water get suspended with the steam, and that we call wet steam. If some particles are there, water particles, then that we call wet steam. Now, wet steam means water particle is there. Then upon continued heating, that particles will be evaporated with time. And if the evaporation complete, that we call dry steam. And for dry steam, in all this phenomenon, you just see gradually the volume increases because pressure is constant. So volume will increase. From ice to water, volume will not increase. Even volume of water is, ice is more than volume of water. But when we heat water, then also there will be not significant increase in volume. Slight negligible amount of volume may increase when it is water. But when the water starts becoming steam, then volume will increase, because steam means it's a vapor stage. So vapor or gases occupies more space at same pressure. And if we complete the evaporation, that means 100% steam, then it will occupy more space. Okay? And if we again heat the dry steam, it will occupy more space. That the volume of superheated steam is represented by V. So volume of dry steam is represented by Vg. That means G stands for gas. Steam is a gaseous phase. And volume of water is represented by Vf. Okay, that means that fluid. In some books it is used as L also. That means volume of the liquid. And the temperature at which water starts boiling is called saturation temperature. Saturation temperature. Now, why saturation temperature? That means temperature is saturated. Temperature will not increase anymore until all the water is converted to steam. And the amount of heat added to the water from water at boiling point to steam at boiling point. You see, water is also at boiling point and steam is also at boiling point. When it takes place? When the evaporation continues for particular time, and during that time we add heat. That amount of heat added to the water to convert water at boiling point to steam at boiling point, or better to say water at saturation temperature to dry steam at saturation temperature, is called, what is this? Latent heat of evaporation. You come back to the melting. When the ice melt, then also temperature remain constant, lower temperature, and that time what happens? The ice is continuously converted to water. So that is also latent heat. Temperature does not increase, and that heat is called latent heat of what? Latent heat of fusion. So melting is also known as fusing. Latent heat of fusion is for melting of ice. That means amount of heat required to convert 1 kg of ice at melting point to 1 kg of water at saturation temperature. This is also saturation temperature. This is called saturation temperature of ice, and this is called saturation temperature of water. Okay, if you have any question, you can ask during this discussion. So till now we get some important terms. Terms are, that I did not say. Now we'll discuss. Now what is sensible heat of ice? What is this? So word sensible is important, because what is sensible? That means we can sense, we can see, we can touch, we can feel from our 5 senses or by using some instrument. When the temperature of ice goes on increasing, when ice is below 0 degree centigrade, then if we add heat, the temperature of ice will increase, and during that time we add some heat. So what is this? Heat, amount of heat during increase of temperature of ice to melting point. During this time temperature increases, and you can see with the help of a thermometer that temperature is increasing. That means we can sense the increase in temperature, and that amount of heat is called sensible heat of ice, because we are working with ice now. Now again see sensible heat of water also. Same thing. When we heat water at a particular temperature, then temperature start increasing, and during that time we can see or we can sense that increase in temperature, and that is called, that amount of heat is called sensible heat of water. And what is this? At 1 atmospheric pressure, 1 atm, what atmospheric pressure, sensible heat of ice at what temperature? Temperature is 0 degree centigrade. At what point it boils? Water at 100 degrees centigrade, boiling point. That is at 1 atmospheric pressure. But at higher pressure, this temperature will be different. Now come to the latent heat of ice. So there is a stage in which if we add heat to the ice, the temperature does not increase. But what happened during that time? During that time, ice starts becoming water. That means phase transformation takes place, but we cannot see any increase in temperature. So if temperature does not increase, it does not mean the heat is wasted. The heat is used to transform ice to, ice is becoming water. And how it is becoming? At T is equal to C. During this time temperature remain constant, and that is why it is called latent heat. The heat is latent within the system, and we cannot see any increase in temperature. So from that the word latent is used. So latent heat of ice means what? The amount of heat required to convert 1 kg of ice at melting point to 1 kg of water at same melting point. That is called latent heat of ice. Now forget about ice. Now come to the water. If water is at boiling point and 100% water, and if we start adding heat to water at boiling point, and there will be no increase in temperature, and that means water starts converted to vapor. That is called vaporization or evaporation. So this amount of heat added to the water at boiling point to form 100% steam, or we can say to complete the evaporation, is called latent heat of evaporation. And this means water is becoming what? Water at boiling point is becoming steam. And during this process, the amount of heat absorbed by the water is called latent heat of vaporization. Now you see saturation temperature. What is saturation temperature? When water starts boiling, this is water. Say this is water, 100% water. It starts boiling, just start boiling. That means temperature is how much? That temperature we call TS, saturation temperature, because beyond this the temperature will not increase. Temperature of water will not increase. That means water starts boiling. Then after some time, if we keep it in a closed chamber, after some time this water will become what? There will be no water after some time. This will be fully steam. That means complete vapor. So in this case also temperature is TS. So this temperature at which the water starts boiling and remains same till the whole of the water is converted to steam, that temperature is called saturation temperature. Saturation means if it is saturated, beyond this nothing will happen. That increase in temperature will not happen. Something will happen, but increase of temperature will not take place. So that is why this temperature is called saturation temperature. So this temperature for water to steam is called saturation temperature of water or steam. And for ice it will be called saturation temperature of ice. Okay. So if it is dry steam, that means there is no water at all. But at this case it is 100% water at boiling point, and this is 100% water at boiling point, and this is 100% steam at same temperature, same boiling point. So this amount of heat is called latent heat of evaporation or vaporization, and the temperature is called saturation temperature. These terms are very important. Now we take one example. Suppose we take 1 kg at Ti degree centigrade. From that example we are taking it. So at point O, this is x and y axis. You see y axis is temperature, x axis is enthalpy. Enthalpy is also called the total heat. So if we add heat, temperature will increase or evaporation or melting will take place. So we start with 1 kg of ice at Ti degree centigrade. Okay, what is the starting point? Ice at Ti degree centigrade. 1 kg. We take 1 kg. So if we add heat to the ice at Ti degree centigrade, then what will happen? The phase is solid. Ice means solid. So the temperature of ice will increase. Up to one point it will increase. The temperature will increase up to this point, OA, up to A point. That temperature we call T0 degree centigrade. That means temperature at which the melting will start. But before that, the temperature will increase from Ti degree centigrade to Ti degree centigrade to T0 degree centigrade. That means this is called sensible. We can see with the help of a thermometer that temperature is increasing, but melting will not take place. So now at point A to B, if we continue heating in the y-axis, that is heating amount of heat. Now you see melting begins. But at point A, that is 100% ice. But at point B, that is 100% water. During this this point from A to B, that is a mixture of solid and liquid, ice plus water. And the amount of heat added during this process, OA, is called sensible heat. And amount of heat added during the melting process is called latent heat. In Assamese, the word latent heat means lean tap. Tap means heat, lean means latent. Latent nihito hoi thaka ba tap, lean hoi thake, nihito hoi thake. That is called lean tap or latent heat. Now when the melting completes, that means 100% water, at what temperature? Same temperature, T0 degree centigrade. For atmospheric pressure, it will be 0 degree centigrade. If we add more heat, then what will happen? The temperature of water will start increasing from point B to point C, and that means we can sense the increase in temperature. That is why it is called, the amount of heat is called sensible heat. Generally this is represented by HF, sensible heat, or total heat of water. Water at melting point to water at boiling point. That is called, water at melting point means water will not melt, ice, melting point of ice to boiling point of water. That amount of heat is called sensible heat of water. And before that, this sensible heat is for ice and this sensible heat is for water. Now if the temperature go on increasing, but at some particular point, Ts degree centigrade, Ts, that is the saturation temperature, and beyond this temperature, the temperature will not increase. But what will happen? Vaporization will start, and that is why this will be a mixture of liquid and vapor, water and steam. So this is represented, say this is the liquid part and this is the vapor part. That means gradually what will happen? Liquid will decrease. If we go towards the right, then liquid will decrease and vapor will increase, amount of liquid and vapor. So at a point D, CD, there will be no more water particles. That means 100% steam. And during this time, when temperature does not change, that means amount of heat added to the water at boiling point or saturation temperature to dry steam at saturation temperature, this amount of heat is called latent heat of evaporation or vaporization. Now we get dry steam. At point D, that is dry steam. So at point D, what is this? 100% steam. Temperature is Ts. At point C, this is 100% water. Temperature is what? Same temperature, Ts degree centigrade. So you can do this experiment at home also for an atmospheric pressure. If you can arrange one thermometer, you take some amount of water in a container, keep on heating, and you see the temperature. So initially you will see that temperature is say room temperature, say 20, at present it is say 35, 34 degrees centigrade, whatever it may be. Then you will read the temperature, and after some time, upon heating, temperature will go on increasing, but after some time it will reach 100 degrees centigrade, but after that temperature will not increase, and at that point actually what is happening, the water starts boiling, and after some time, if you go on heating, there will be no water in the container. Everything will be evaporated because we are not contain the water in a closed chamber. The water will vapor will actually go to the atmosphere, because it is open to the atmosphere, but there will be no water, and that point also the temperature will be 100 degrees centigrade. So after dry steam, if we add more heat to the system, that temperature will again start increasing. Then that type of steam is called superheated steam, and the amount of heat is called heat of superheat. Superheat. The amount of heat called enthalpy of superheat. Now this total heat, this term is the substitute for enthalpy, that we also call enthalpy. The same enthalpy we discussed in the previous classes. So total heat H, that means enthalpy. So this way the phase transformation takes place, and there are some important terms. Now look at this diagram. Again we will discuss. So say we are considering the temperature and enthalpy. In the y-axis it is temperature, in the x-axis it is enthalpy. Now enthalpy means what? Total heat. That means amount of heat added to the system. Now we start with 1 kg of ice at Ti degree centigrade. This is the point O, and this temperature is Ti degree centigrade. So if we add heat to the ice at Ti degree centigrade, then what will happen? From O to A, the temperature will increase, and this temperature we call T0 degrees centigrade. That means melting point of ice. That is called melting point of ice. And during this time, the solid, it will remain solid. This is solid ice. Okay, and this amount of heat, O to A, small a, O to small a, this amount of heat is called sensible heat of ice. Now if we add more heat to the system, then what will happen? Now we have at point 1, what is this? Now if we add more heat, then what will happen? From point A to point B, the solid will go on decreasing and liquid will go on increasing. At point B, there will be no more solid, and this is called melting. Whole melting process completes. Melting begins or starts at point A, and melting completes at point B. And during this period, this is a mixture of ice and water, or solid and liquid, and this is called latent heat. The amount of heat added from A to B is called latent heat of melting, or latent heat of fusion, because fusion takes place. Fusion means melting, solid to liquid. Now if we go on adding heat from point B also, then what will happen? You see, from B to C, during this time the temperatures start increasing, but it is remain water, 100% water. At point B also it is 100% water, but at point C also it is 100% water. The only difference is the temperature changes from T0 degree centigrade to Ts degree centigrade. So Ts is called the saturation temperature of water. Why saturation? Beyond this temperature will not increase. At this time this is 100% liquid or water. From B to C, okay? From B to C it is water, and this OA, this is B, this is C. Now O to B, this whole amount of heat, this is called total heat, and A to B, this is called latent heat of fusion, and B to C is called sensible heat of water. Sensible heat, because temperature is increasing. Now if we continue our heating process, then what will happen? Now temperature will not increase, because it is 100% water at saturation temperature. This Ts is called the saturation temperature. This is called saturation temperature. That means temperature will not increase anymore until the whole water is converted to steam. So from C to D, this is liquid plus vapor, or we can say water plus steam. At point C, it is 100% water at Ts degree centigrade, and at point D, this is 100% steam at Ts degree centigrade. And this steam is generally called wet steam. Why wet? That means it is steam still, but steam has got some water particles. and amount of water particles at point C is 100% and amount of water particles at point D is 0%. And this is called latent heat. Okay, this amount of heat is called latent heat. So C to D, this is called latent heat, and this is represented by HFG, and this part is represented by HF. That we will discuss in details in the later classes. So latent heat of vaporization or latent heat of evaporation. Now this is a dry steam. At point D, this is 100% steam. If we add more heat, then dry steam will be, temperature of dry steam will increase, and that phenomenon process is called superheating. So suppose we increase the temperature up to TE, and at this point, this will call, at this point, this temperature we will call T sup, temperature of superheated steam, and this D2 is called superheat. The amount of heat is called superheat. Why superheat? It makes the steam super steam, and that type of steam is called superheated steam. And this is what steam? Dry to superheated. At point D it is dry, from dry to super dry. We can say super dry, better to say superheated steam. And this way the formation of steam has some interesting thing, but we will not consider in our discussion. We will not after this we will not consider from solid, because generally we produce steam from water at atmospheric temperature, which is generally more than 0 degrees centigrade. Okay, so fine. If you have any question. Okay, now one more point. We got, what is a wet steam?
A mixture of both steam and water.
Good. So mixture of water particles and steam. In nature, when we say steam, if you boil some water at home, then what we see, that the water get evaporated and we can see something is going to the atmosphere. Actually that is not dry steam. That steam is carrying, there are some steam, but that steam is carrying some water particles also, and that type of steam is called wet steam. But we can, if you can hold that steam and heat more, then that water particle will be evaporated. And if you can do that and convert all the water particles to steam, at that point it will be called dry steam. That means for dry steam there is not a single water particles, and for wet steam a part of the steam is water particle in suspension, upongi thake, and a part is dry steam. And of course we know if we add heat to the dry steam, then it will be superheated steam. Now what is the temperature of wet steam and dry steam? That we call TS, saturation temperature. Temperature is same. Saturation temperature of wet steam is same as saturation temperature of dry steam. Same temperature. At the same temperature, steam may be wet steam. Why wet? Wet means water. Generally by wet we mean water. That means steam that contains water is called wet steam. And dry steam means steam that has no water particles at all is called dry steam. Okay? Now, you see, just consider, this is 1 kg of what? The yellow dots are, suppose, water particles. Yellow dots, okay? And the blue dots are steam. Now that means this is steam, definitely this is steam. And what type of steam it will be? What will you call this steam?
Wet steam.
Wet steam. So this wet steam, that means there are steam, blue dots are steam, but these yellow dots are water particles suspended with the steam. So this is wet steam. That means they contain some amount of water. Now if we add more heat to this, if we add continue heat supply, then what will happen? These water particles, yellow dots, whatever is there in a suspension, that water particles will absorb the heat and that water will become again steam. Then at some point all water particles will be converted to steam, and that stage is called dry steam. So what is dry steam? There is not a single yellow particles in this case. So yellow particles means water particles. So in this case there is no water particles, but the temperature is in this case also Ts, and in this case also it is Ts, saturation temperature. Now if we continue heating this, that means if we add more heat to the dry steam, then what will happen? It will remain steam. But I am representing this steam with some this pink, this color is pink color dots. That means what is the difference between this steam and this steam? It is steam. Dry steam also 100% steam, and superheated steam is also 100% steam. Remember, this is also 100% steam and this is also 100% steam. Now what is the difference?
Temperature is more at superheated steam.
Excellent. So T sub, this we call T sub degree centigrade. That means T sub is greater than Ts. So after saturated dry steam, if we add heat, we will get superheated steam at some temperature, that is called super T sub, temperature of this superheated steam. Now you see, so wet steam contain what? What is there in the wet steam? What are the things that wet steam have? It contains dry steam as well as water particles. That means steam plus water, liquid plus vapor. That type of steam is called wet steam. That means wet steam may be of different qualities. Sometimes wet steam may have more water particles, and sometimes wet steam may have less water particles. And for that we can explain this like this. Say this is the wet steam. Now suppose this is 100%, not this water plus steam is 100%, or we can call this 1. So this whole thing can be represented by a pie diagram. Whole circle means 100%. Out of this, red part is say steam. That means there are maximum amount of steam, but a little amount of water particle is there, 5%. 95% is steam and 5% is water particles. And if we express this out of 1 means what? 0.95, say 1 kg. So 0.95 kg of dry steam and 0.05 kg of water particles. So total become 1. In percentage we will call 95% and 5%. Dryness fraction means what fraction is dry. So in this case, what fraction is dry? 0.95. This fraction is dry out of 1. So let us take another example. Suppose we have some other quality of steam, that is called quality of steam. Suppose this steam is 70% is steam, that means dry, and 25% is water particles. In that case, we will call dryness fraction is 0.75. That means out of 1, 0.75 kg is, out of 1 kg, 0.5 kg is dry part and 0.25 kg is wet part. So this way we can express quality of steam. What steam? Wet steam quality you have to express. By what we explain? It is expressed by dryness fraction, dF. What is this? dF, the amount of dry steam divided by total steam. What is total steam? Total steam in this case is 1, and amount is how much is dry? 0.75. So that is why dryness fraction is 0.75. We can also say 75% is dry and 100% is total. So it become again what? 0.75. So this 0.75 is called the dryness fraction of steam. So from now onwards we can understand what is dryness fraction. Dryness fraction means if the dryness fraction is more, that means that steam has less particles, water particles. Now tell me, what is the dryness fraction of 100% dry steam? Yes, anybody? What is the dryness fraction of 100% dry steam?
1.
1, good. That means